Intelligent database, your database on Autopilot. Thank you all for joining this Wednesday morning for this session. Today we will talk about the intelligent database capabilities, and we prepared a great session for you guys. It will have 3 sections. We will cover the performance-related intelligent features, then security-related intelligent features, and then we will tell you about a customer success story from our dear customer, Finastra. There will be a couple of us speaking, and as you see, I will start. My name is Veljko, and let's get started. So, as we started developing Azure SQL Database in its early days, we realized that it will be pretty hard to scale out ourselves to have this global service that's run across the globe. We realized that we will need to invest a lot of time in understanding what is happening with all of these databases and knowing how we can resolve the issues or improve the performance of the databases. That's when it all started. We started working on these intelligent database capabilities early on, and we use them for ourselves to understand what is happening with the databases as they were having some kind of issues or performance problems. As this technology matured, we shaped it into features that are now part of Azure SQL Database that you can all use and benefit from. Today, Azure SQL Database understands your workload. It learns from millions of databases across our service, and it can automatically tune itself and alert you on threats and vulnerabilities. As one of our architects said, we are living in a world where 1 in a million events happen daily, and we truly are. And we had an opportunity to see various kinds of problems that our customers are facing with their databases. All of these problems that are seen on Azure SQL Database tie into these intelligent database capabilities. And these capabilities continuously evolve and grow. I'll cover the performance-related intelligent features. And we have 2 features that I'll talk about today: intelligent insights and automatic tuning. We'll start off with intelligent insights. So as your databases are working and executing their workload on Azure SQL Database, their workload pattern is being continuously monitored. We create the baseline for all of your queries of all of your databases running on Azure SQL Database. This baseline is used to be compared with current database performance. Think about this baseline as a 7-day window of your performance and the statistics about how the queries are performing, how long are they being executed, etc. Intelligent insights and Azure SQL Database can detect disruptive events that cause poor performance. Once this disruptive event is detected, the root cause analysis is done. This root cause analysis contains information about which queries were relevant for these issues, what was happening on the database, did any base statistics spike at that time, giving you an insight into this performance issue. Intelligent insights are available as a diagnostic log. Think about it as an error log that you can stream or store and use it for monitoring of your databases. You can stream the intelligent insights and other diagnostic logs that I'll show you in the demo into 3 targets: Azure SQL Analytics Solution, Event Hub, or Azure Storage. All of these 3 different targets have different purposes and use cases. So for example, if you want to store these intelligent insights and other logs for archival purposes, where somewhere in about a year from now, you want to go back and compare what was the performance and what were the things happening on your databases, you would store it into Azure Storage. That's a cheap way to store lots of data that you can, when needed, ingest into some database engine and run some analytics on top. If you, for example, have your own monitoring solution or your own monitoring pipelines from your application or other components from your stack, you can stream the intelligent insights into Event Hub, giving you a nice way to integrate these additional logs with your own telemetry that you're already collecting. But if you're looking for out-of-the-box solution for monitoring your fleet of databases, you would stream the intelligent insights and other logs into Azure SQL Analytics. Now, let me show you how this all looks. What I have here on the screen is Azure Portal that I will use for this demo. Azure SQL Analytics is part of Log Analytics service that you can look at as a single pane of glass for monitoring your whole application stack. Log Analytics has various solutions that you can install. So you could install the solution for monitoring your web applications, for monitoring your VMs, or for monitoring all of the things that are happening with all of your Azure resources, like who is creating the resources, who is dropping them, who is changing them. In addition to all of these solutions, there is a solution called Azure SQL Analytics that I mentioned that you can use for monitoring a fleet of databases. On this dashboard, I have Azure SQL Analytics solution pinned. And clicking on it, I will open up the solution. As the solution loads, you can see there are various charts and a single table available here. And let me briefly go through and explain what are all of these things. On the left side, we have a table with a list of all of the databases that I'm monitoring. With this solution, I'm monitoring 1,700 databases at this moment. These databases are executing some workload that I previously prepared. And as you can see, in the table on the left, we see the list of databases. We see the leading metric of this database, the metric that is most utilized. It can be storage, CPU, log I/O, etc. And you can see the value. How much is this resource dimension utilized? On the right side, there are a couple of charts. Let me briefly explain them. You can see out of all of your databases, how much they're utilized in the top left chart. Blue color represents the databases that are called and not utilized a lot. Green one is the databases that are medium utilized. Think about it between 20 and 80% of the resource utilization. And at the top, there is a thin orange line that some of you in the back might not be able to see. On the chart below, I see the number of databases out of these 1,700 databases that are having some kind of performance issues. Issues are also categorized as high, medium, and low. And here I have only low impact and medium impact issues that are happening. Charts on the right give me an overview of the performance across my databases. Top left chart contains the query duration information of all of the queries that are being executed across all of my databases. I can see the max duration of the queries, the line on the top, and I can see on the bottom the orange line that's close to 0 that represents the average duration of all of my queries across all of these databases. Below, I can see the information about wait statistics, what are my queries and what are my databases waiting for. And on the right side, I see the number of problematic events, such as errors, timeouts, and blocking events. Now remember, this is a view of your fleet of databases. So if any of my databases all of a sudden started having timeouts, a large number of timeouts or a large number of blocking events, that would be represented in these charts. But this is like a bird's eye view of my fleet of databases. So I can actually go in and dig deeper to see what is happening, where are these timeouts coming from, for example. So I'll click on this tile, and I get another report that gives me this hierarchical overview of the timeouts happening across all of my databases. Let me zoom in a little bit and explain. Each of this table represents another hierarchical level of my Azure SQL database. So I have the aggregated number, the total amount of timeouts on my different subscriptions, but I also see the same number for my servers, elastic pools, and individual databases. Chart on the top of each of these tables represents per resource this aggregated number. So for example, here, I can quickly see that yesterday at around 6 p.m., this database had 129 timeouts. I can see similar information across this time period for all of my databases. Let me go back for a second and show you another view I really like, and that's this query duration view. This aggregated number that I'm currently seeing tells me if I have some kind of outlier, some query that its duration is quite high. And I want to go in and investigate deeper. Clicking on this tile, I can actually again see the aggregated information on the different hierarchical levels, telling me the average and the max duration of the queries, of all of the queries under these resources. So for a subscription number 1 in the table, I have around 100 of databases, and all of the other databases are coming from the subscription below. And these aggregated numbers help me narrow down my investigation. This is a familiar pattern, like the one we saw with timeouts. So we have the same aggregated statistics on the server level, elastic pool level, and on the database level. But let me show you one more thing. I want to focus my investigation to a single server. I quickly filter out the servers I'm interested in, and I will select one. Now I drilled into the report, and I scoped my report to this server only. So now I see the queries and the databases under the selected server. And let me show you. Again, under this server, I have a single elastic pool. I have a list of databases, and I can see these aggregated statistics. But I have a different slice as well, slice per query, telling me how this specific query is performing across all of the databases in this server. And I can quickly see that there are some queries that have max duration much longer than the average. I can see the number of executions of these queries from this view quickly. Let's say I'm interested in this query over here. It's being executed quite often. This is around 1 million of executions. And it has quite a big difference between max and the average. Max is 33 seconds, while the average is about a half of a second. Selecting this row in the table, I will actually go into cross-database view of this query. So on the left side, I have the query text. This is the query text that is being executed across my different databases. But if I go a little bit to the right, I can see how this query is behaving on each database individually. So you can see the chart on the top telling you the max duration of this query across all of the databases in the selected server. And you can see the average line. But you can see for each database individually in the table, how long did it took on database A or on database B. To give you more context about these databases, this is actually a set of databases that have the same schema. Think about it as I'm a SaaS provider, like a software as a service provider. All of my databases have the same schema, and my different users get their own database. It's like a database per tenant. Now I have this single query that's misbehaving, but it's misbehaving only on some of my databases. To get this information, I need to take a look at each database individually, but not with Azure SQL Analytics solution, because I get this slice of the query performance across my databases, helping me easily figure out where this query is misbehaving. This can point me to a particular problem that I can discover. Let's say a database A, this query is taking much longer because there is some table that actually grew a lot in last couple of days compared to the database B where it didn't grow. So as you can see, Azure SQL Database is not a black box. There is a lot of telemetry that is available for you to monitor and keep control of your databases. But this is not how this session started. We are talking about the intelligent database capabilities, right? So let me go into intelligent insights. We don't actually want you to go and compare the query performance on a single database versus the other, then dig deeper into the weight statistics, compare the weight statistics, and do the correlation of the performance and the different weight statistics. We want to help you out and give you this information out of the box. So as I mentioned, this chart over here is my entry point into the intelligent insights. And I can see that I have around 100 of databases that are continuously having some kind of a problem. I will select this tile, and I'll go into this aggregated statistical view, telling me on a single subscription how many high impacting problems I have, how many medium, and how many low impacting problems I have. On the server level, Elastic Pool level, and for each individual database, I can see what is the level of performance impact it had in the last day. I will select a single database, and I get this database report. On the left side, I see the chart that I will explain in a moment. But I also see here this insight report. And it tells me when did the issue with this database start, when was the issue the worst, when was my database the most impacted, and what was the issue at the end. So let me scroll down a little bit and read parts of this report quickly for you. So this intelligent insight report is telling me, your query compile time has increased. We have noticed that there is a SQL weight type that increased as well. And in addition to this, the Elastic Pool, where this database is hitting its limits. So the databases are competing for resources, impacting the performance of this database in particular. It even gives me a verbal recommendation. Consider moving this database to another Elastic Pool. This is your first checkpoint when you have a performance issue. Something is wrong, you get an alert, or somebody calls you to check on the database. First, you come to the intelligent insights to see what did the system assess regarding this problem, what the system thinks is the problem. The chart above gives me the timeline of the problem. And I'll quickly read it for you as well. The orange bar represents that the database experienced the problem because the Elastic Pool was hitting the DTU limits. And the purple bar tells me that the weight statistics increased. So this way, I can follow the life cycle of an issue through time. In addition to these intelligent insights, I have the information about the query duration and what these queries are waiting for on this particular database. I have the information about database weights. If there were any errors, I would have errors, timeouts, and blockings in this table, and so on. All right. So to recap, Azure SQL Database is continuously monitoring its performance. It detects disruptive events that cause poor performance and automatically provides root cause analysis. It's available as a diagnostic log that you can stream into 3 different targets, allowing you for various use cases. If you're looking for out-of-the-box solution for monitoring your fleet of databases, Azure SQL Analytics is your answer. The second feature that I want to cover today is called automatic tuning. And as I said, Azure SQL Database continuously monitors the database performance. But in addition to detecting these disruptive events, it also recognizes the optimization opportunities. Once this opportunity is recognized, it will track how the workload is, what is the workload pattern that is happening. And once the confidence is built, this optimization will be applied as part of automatic tuning. Automatic tuning is really simple to enable, and it can work in 2 modes. In auto mode, where it automatically applies these optimizations for you, or in manual mode, where it gives you the recommendations, telling you, hey, consider doing this. It's very simple to enable, and I'll show you in the demo. And it doesn't require any application changes. There are 3 tuning operations that automatic tuning is capable of doing today, and that's create a missing index, drop unused or duplicate index, and force last good plan. And let me jump right into the demo. All right, so we created this little app, and you can see how the application looks like when Program Manager is doing the coding. So we have a simple gauge on the left side. It's showing me the number of requests that are being executed on the database by this application. And on the right side, there is a T-SQL text that is actually the query that is being executed. And you see it's a simple query. It finds an average over a table with where clausula. But the thing is, this table is highly skewed. So if I send a specific parameter, the plan that gets compiled will not be optimal for all the other parameters that are in this table. But with enabling this force last good plan automatic tuning option, I can get this thing to self-correct. By clicking on this on button on the right side, I will actually enable force last good plan. You see the T-SQL syntax here, how you can enable this thing through T-SQL. And later I will show you how you can enable it through Azure Portal as well. So what is happening right now is that this database is learning the workload patterns that are happening. And it's learning the statistics, how good and how performant this query is being executed. And when I click on this regression button, what will happen is that I will clear the cache of all the plans that I have, and I will send a specific query with the problematic parameter that will make SQL Server compile the plan that is optimal only for that parameter, but no other parameters. You will see, as I click here, that the number of requests are dropping. In the back end, SQL Server is now comparing the new performance of the query with the previous performance. And as you can see, it figured out that previously used plan was a better plan, and it started forcing this plan. This is a problem that's known as plan regression. Usually happens in the middle of the night when nobody's there, so you get a call and you need to go and fix it. With automatic tuning, this problem goes away automatically. Automatic tuning monitors the database and jumps in and starts forcing the right plan when the time is right. I want to show you a little bit more about automatic tuning. I will go back to my portal, and I'll open up a single database. I will scroll a little bit down, and I will hit this performance recommendations menu item. Here, I can see the recommendations that exist on this database. I see a create index recommendation that's available, and I see some recommendations in tuning history that were previously applied. What's really important about automatic tuning is it takes care of user workload. So it will not apply the recommendation while your workload and resource utilization is high. So if I would go on and apply this index recommendation, it goes down in the table, and it's now in pending mode. It will wait for the right time when my resource utilization drops in order to create this index, so it doesn't interfere with your workload. In addition to this, I said automatic tuning does not require code changes. And that's a really important thing, because we want this feature to be as simple as possible for you. You enable it, and you stop worrying about it. So what happens if automatic tuning creates an index over a column that you want to drop? If you create a regular index and then try dropping the column on top of which the index is created, the operation will fail. Well, not with automatically created indexes. These indexes will move out of the way, allowing you to do whatever you want with your schema. They will be there as long as they are needed. And if you want to drop the column, they'll just be dropped with the column as well. After the optimization is applied, automatic tuning did not finish its job yet. It will actually start comparing the new performance after the optimization was applied with the previous performance that it had, like with intelligent insights. Just this time, it is looking for the benefits. How much did the workload benefit from this optimization? If there is no benefits for the workload, automatic tuning will self-correct. It will revert to the recommendation, keeping your performance optimal, making sure that your performance only improves with automatic tuning. In addition to this, if there were benefits, you will actually get a nice report that will tell you what were these benefits. So I'll click on one of the recommendations that was previously validated. And here, I'll quickly show you. The validation report tells me how much DTU I have saved, how many queries did improve, what was the disk space that was used for this index, when was the index actually created, all of this information. It also contains the information about the index name, index type, the table, schema included, and indexed columns. And to show you one more thing, you can actually use these recommendations and tie them back into your code. So on top bar, I have this View Script button. If I click View Script, I'll see the command that I need to execute in order to revert the recommendation. But if I'm interested in how to apply this recommendation and tie it back into my code, if I look at the recommendation that is currently active as the one that I previously applied, using the same View Script button, I'll be able to see what is the exact T-SQL query for creating that index. So I can use that and tie it back into my source code. And at the end, I want to show you how is automatic tuning enabled through the portal. On the bottom left side, I have this automatic tuning menu item. Clicking on it, I'm able to see my current configuration of automatic tuning. And I can actually choose what are the settings that I want. I can explicitly say I want to enable /good plan, create index, drop index. But I can also say I want to inherit settings from my server, making sure that all of my databases are following the same policy. They all have the same configuration applied. I can configure automatic tuning on the database level, but also on the server level. That way, as the new databases get created under this server, they will automatically inherit the settings, helping me manage this configuration at scale for all of my databases. All right, quick recap. With automatic tuning, a feature that's very simple to enable, you get continuous tuning automatically done by the service that keeps improving your performance, that doesn't require any app changes, and it's really simple to use. There are 3 operations that automatic tuning can do today: create index, drop index, and /good plan. Thank you all for listening. I would like to invite my colleague, Ronit, to tell you all about the security-related features.
Hey, everyone. OK. So now that we've heard from Veljko about the amazing intelligent performance features that we have in SQL, intelligent insights, which lets you easily discover disruptive events and get to the root cause analysis just kind of automatically, which is amazing. The magic of automatic tuning, which automatically fixes performance problems in your database. These are amazing, intelligent features that really let Azure SQL Database do your work for you from the database perspective. And now we're going to flip into a different area of intelligence that we have in Azure SQL Database, and that's the area of security. And we'll be talking about a few advanced security capabilities that we have for Azure SQL Database that also use the intelligence of the cloud database to help you secure your data. So with security, we always start with a little bit of motivation, right? Why is security really important for your database? And actually, it used to be that we had to convince people that it was important, but recently we hear so much talk about these different data breaches, whether it's Equifax or Yahoo or other data breaches where just tons of sensitive data is being stolen. I think the motivation part is much easier these days to get through. But when you go and analyze the actual data about what's going on, we really do find that these data breaches affect every single industry. Really, there's no industry that's immune to security breaches, to data breaches. Everyone needs to think about protecting their data. And it's also pretty obvious, I guess, but the research really does show that the #1 kind of attacked asset is the database. The database is, the heart of where your data is kept in the organization. That's what the attackers are going for, the crown jewels of data that you have that's important and that could be interesting to steal. And we also see what types of attacks are taking place. So while we hear a lot about the sort of outsider attacks, and that is the majority, over 70% are outsider attacks, but there are also a lot of malicious insiders that ultimately manage to attack the database or basically breach the important data from your database. So some common threats that we see, a lot have to do with, again, if you're looking at the database, things like SQL injection. SQL injection is your classic database attack that, although it's been around for a really long time, we find that's still a pretty effective way to steal data, and we see that it happens a lot. And then we hear about password cracking, credential theft, privilege abuse. Again, this is what the insiders use to get at our sensitive data. Now, when we talk to customers, then beyond actually just protecting their data, they also have compliance requirements that they have to meet. And there are all sorts of regulations that demand that we do protect and lock down our data and database security as best possible and according to the standards that they define. So whether it's industry-specific regulations like PCI and HIPAA and so on, now there's also the GDPR. Can I see a quick show of hands who's heard of the GDPR? Yeah, about half of you, I think. And the other half will soon enough, because it goes into effect in a couple of weeks. This is a new data privacy regulation that's coming out of Europe, again, going into effect very soon. And it really has some pretty stringent requirements of how to protect data privacy and how to protect data. So in order to meet these requirements and in order to protect our data, there are a few different things we need to do to secure the database. And these are the types of things that we, the SQL team, have been working on to help meet these types of requirements. So it starts with discovering where the sensitive data actually is. Okay, what is it that we need to be protecting? We then identify where the vulnerabilities could potentially be ahead of time and try to remediate those so that we're less exposed. Following that, we actually want to monitor as the database is up and live and working and see if we can detect suspicious activities and give information about what's going on with anything suspicious and enable remediating that. And then, of course, you actually have to meet the requirements that these regulations are demanding. So in order to address all of these requirements, we're actually introducing, right now, we're introducing a new kind of intelligent security package that we call SQL Advanced Threat Protection. And this includes capabilities across the scope of these kind of intelligent security abilities to help exactly meet those requirements, to help discover and classify sensitive data, to help identify vulnerabilities in the database and address them and remediate them, to identify suspicious data activities, database activities, and help you remediate those. And this is all being offered in sort of a unified advanced security package. Again, it's called Advanced Threat Protection, or SQL ATP. That might sound familiar. We have our Windows ATP Advanced Threat Protection offering. We have our O365 ATP. And so now SQL has this Advanced Threat Protection offering as well. So we're going to go into a little bit of detail about each of the different offerings here. Again, these advanced and intelligent security offerings. And I'll spend most of the time showing you how they work in a demo. So starting with SQL Vulnerability Assessment. This is a fairly new service. It's soon to be generally available, currently still in preview. And the vulnerability assessment basically gives you a sort of central security dashboard for your databases. So it shows you what your current security stature is, where your potential vulnerabilities are, and points you exactly to where those vulnerabilities are with information on why they're a vulnerability, why they impact your security, and gives you actionable information for how to actually lock down your database and remediate those vulnerabilities. So the result of an assessment is basically a vulnerability scan on your database that kind of happens in the background, that happens on your database based on knowledge, again, the intelligence that we have in Azure SQL DB, knowledge of what types of vulnerabilities are actually effective in exposing your data. You then get a coherent report that describes exactly what your current status is, and that can be used for compliance requirements, as we spoke about before. And you can actually create a policy to tune the results of this report to your environment. So what does that mean? You have a set of requirements on your database. For example, what should be the permissions? What types of features are actually in use, and what kind of protection features do you have available? You have the requirements that you need, and you can actually basically tune the result and say, okay, this is my security baseline. This is what is right for my environment. It should be as locked down as possible, but still enable your database to do the work it needs to do. Then from that point on, the vulnerability assessment will expect your specific customized values and notify you only about deviations or drift from your secure baseline state. Okay, and this capability of the vulnerability assessment is available for Azure SQL Database and also for your SQL Server on premises. We support SQL Server 2012 and up, and you can find that in the most recent SSMS SQL Server Management Studio, which is the database management tool, you can find the vulnerability assessment built in there. So that's vulnerability assessment. Again, I'll show this live in a couple minutes with a demo. The next feature I wanted to talk about, the next kind of intelligent security feature, is what we call SQL information protection. This is basically the capability of discovering where your sensitive data is, automatically classifying it, and enabling you to actually label that data as sensitive, basically approve that automatic classification, label that data as sensitive, and then apply protection policies based on the sensitivity of that data. Okay, this is going to be a very crucial capability for example, identifying data that qualifies for the GDPR, right? Which is personal identifiable data, data that can be linked back to an individual. This will help you track down where that data is within your database or databases, and be able to, again, have a report showing where that is, where your sensitive data resides, and also tracking where that data goes, and ultimately protecting that sensitive data. So this too is available built into Azure SQL Database, currently in preview, and it's also available for, as in a limited way, for your on-premise SQL Server, also built into SSMS. You can check it out. You can run this to find sensitive data in your database and classify that data. And the final intelligent feature that's part of SQL Advanced Threat Protection is what we call SQL Threat Detection. So this is the capability that basically monitors your database activity all the time and looks for suspicious or anomalous events. We can think about it similar to what Velko was talking about with our intelligent insights, right? That's detecting disruptive events from a performance standpoint. So this is detecting anything that could be suspicious from a security standpoint. So when we detect any anomalous activities, and that could be, for example, potential SQL injection attempts, which we know how to identify, or anomalous activities like an unusual principal that's logging into your database, or an unusual amount of data that's being exfiltrated from your database, or perhaps someone accessing your database from an unusual location, which is suspicious. So anytime we detect anything like that, again, based on the baseline that we know for your database usual activity, then we'll immediately notify you. So you'll get a notification via email and also in the portal and in the central Azure Security Center, which I'll show you, that kind of centralizes all this information. And you'll get actionable information for, again, how to, first of all, investigate the issue. So you can then go and see exactly what took place, understand what this potential attack on your database could be, investigate if it really is an attack, and then information on how to remediate the issue. So with that, I'd like to jump into a demo and show you all these different capabilities in action. So I have this sample database here in my Azure portal that I set up in order to look at these security capabilities. And what I'd like to show you here is, again, this new security package that we have called Advanced Threat Protection. You can find it here under Settings. This is actually going to be revamped very soon, so it'll be easier to find. You'll actually find in a couple of weeks, if you go to the portal, you'll see this new security section that enables you to find the security capabilities in a much more easy way. But if I click on Advanced Threat Protection, again, this is the package that basically unifies all of these kind of advanced security capabilities for your database. This package is billed at $15 for your SQL Server per month, and it automatically includes all of these advanced capabilities and any additional advanced capabilities that we'll be adding as time goes on. So you see that you have, within SQL ATP, this sort of centralized dashboard that shows you what's the status for these various capabilities on your database. So for the data discovery and classification element of our information protection offering, you can see, okay, here is the sort of overview of where is my sensitive data, what type of sensitive data do I have in this database, right? This is a view for a particular database. And in addition, what recommendations do I have for additional potentially sensitive data? We'll look at that in more detail in a moment. For the vulnerability assessment, I can see, according to the assessment, what are the current vulnerabilities? What's the current security status of my database? What are the current vulnerabilities found? And I can go in and see the details there. And for threat detection, I have this overview of what the current alerts I have on my database. So this is the centralized view. And then we can start kind of diving in into the details. So if we do start with a vulnerability assessment, then this will open up my main vulnerability assessment screen. As we said before, this is sort of our central dashboard for managing the current security status from a preventive perspective of what current vulnerabilities do I have in my database, what do I need to do to improve the security. So what we see in the dashboard at the top is basically an overview of here's my current security status. These are the number of failing checks that need to be addressed, and also the number of passing checks, and kind of a breakdown according to the risk, the perceived risk that we've assigned to the different vulnerabilities that we've found. And then below you immediately have basically a list of action items. These are the failing checks. These are the things that you need to address to improve and lock down your security. And they are sorted according to order by, again, the perceived risk. So you can start working through this list, starting with the highest risk items and working your way down. And again, the type of things that we're checking for here are excessive permissions, are all sorts of settings that are not aligned with best practices for securing your database. We're looking at excessive surface area, right? Things like features that are enabled that maybe don't need to be, and they could be a way to expose data and access your data in unexpected ways. And we're also looking at basically, do you have all the necessary security features enabled on your database that can help with security issues? Things like auditing. Do you have auditing enabled, which is critical for being able to investigate what's taking place, what types of activities are taking place on your database? Do you have threat detection enabled? Those kinds of things. And so here you see, again, a list of the failed items. You also have a full list of all the passing checks. So you always have full visibility into exactly what we're checking, what we're looking for, and what kind of created this report. How do we actually reach this? How do we actually scan for the database or scan for the vulnerabilities? You have this scan button up here that shows you that you can actually click on and scan immediately. But if you go into the settings, you can actually, this is kind of a new capability now, you can actually turn on periodic scans. So this will just automatically run a scan on your database in the background. Once a week at this point is what we're supporting. And if I put in my email address, it will send me reports every time that completes with the current status of my assessment on my database. So let's drill down and see what kind of vulnerabilities we have here. So the first item on the list, if you can see that, maybe zoom it a little bit, is that the assessment found that I have, or is advising me, that a minimal set of principals should be members of high-impact database roles. So if I click on here, then I actually can get some details about what that means. So this explains to me that we're actually looking at your permissions. We advise that you have a minimal set of SQL principals or SQL users that can be members of these high-impact database roles that can perform a lot of activities on the database. And the idea is to adhere to the principle of least privilege, right? Any user has only the permissions that they need to do their job on the database. And that way you're avoiding excessive exposure. So we explain all this to you. We give information, including the security impact. Why is this important for your security? We provide the actual query that we're running on the database in order to get this information. So you can take that, go run it yourself, figure out what we're looking for with all those details. And then we show you the results. So the results in this case are that these two users were found to be members of this high-impact database role. And the remediation here, which we always provide also remediation, is you should be removing any members that aren't necessary. And not only do we explain that that's what you should do, we actually give you a script to go and actually do that, to actually remediate the issue. So this script, if I run it, will actually go and remove these two users from these roles. And I can actually run that here directly in the query editor in the Azure portal. So if I click on here and I quickly log in, Oh, that's not right. Then I will see that that query, that remediation query comes up, and all I have to do is click on Run, and it will remove these 2 users from that role. So I'm not going to do that right now, but I'll show you that later. Another alternative I have here is to say, okay, well, yeah, these 2 users are members of this role, but these are my 2 administrators that need to have this access. This is actually the right value for my environment. So in that case, what I would do is actually set this as my security baseline. This is the right value that I should have here. And if I approve this as my baseline, I just click up here, Approve as Baseline. And that means that from this point on, the assessment will expect exactly this value, exactly these 2 users as part of this role, and it will notify me only if there are deviations from that. So if suddenly another user has these privileges, then the assessment will alert me about that. You can see some other examples of things that we're checking for here. We're looking at your firewall rules to make sure they're locked down, another rule about excessive permissions, a rule about orphan roles that should be removed, for example. And again, they all have the same concept of, here's the description, here's the security impact, here is the result that we found, and the actual script to resolve the issue. What's that? Yeah, so you're asking me to click through the sensitive data one, and that's kind of a great lead into exactly what I was going to do. It's going to show you the sensitive data one, which actually leads into our data discovery and classification. Perfect. So just a couple of last words about the assessment. You also have a report that you can actually download. So if you need to provide a report to auditors for compliance, for whatever purposes, you can just click on Export, and this will actually create an Excel report that I can then share with whomever I need to share. And that Excel report looks very similar to this report, where you have all the data about the kind of overview and also the individual vulnerabilities. I had one open, but it's opening this one too. Okay. So it looks like that, and you have all the details for each one of the checks that we ran over here under results, each one of the checks, each one of the results. So you have all those details in the report. Okay, so that's pretty much a vulnerability assessment. And then the question came here, hey, can you show us what that sensitive data rule looks at? So that's exactly what I was going to do. One of our recommendations is that your sensitive data columns should be classified. So what does that mean? Again, we're using the data discovery and classification capability to go and basically look through the metadata in your database and discover what we think could potentially be sensitive data. And when we do, then what we advise you to do with that is to go and actually label that data with a sensitivity label in your system so that you can then track that this is the sensitive data that you have, so that you can get reports, and so that you can track how that data is being used. So that's what this is all explaining. And then the result here is all of these different columns. And you can see there the column names here that we found that could potentially be sensitive, like username, CC number, city, email, all these different things that could potentially be sensitive in your database. And not only do we find these, but we also give you an automatic classification according to what we think the classification here should be. So what is the information type, and what is the recommended sensitivity label? Is this confidential? Is this highly confidential? Is this related to GDPR? Those types of labels. Now the action item here is to actually go and apply classifications to these columns. So if I click here on the remediation, this brings me directly into the data discovery and classification view. So we also could have gotten here from the advanced threat protection main dashboard, but we can also get here through the assessment, which again will notify us of any updates with our data classification status. Now what we see here in the overview is I've actually already classified some of the data in this database, and I can see that the chart over there on the left actually shows what the current breakdown is of sensitivity. So I have a few items that are classified as confidential GDPR, a few that are highly confidential, a few that are just confidential and a few that are highly confidential GDPR. And I also have a breakdown of the information types. So again, we also classify according to distinct set of categories that we call information types, and we can see the different types of sensitive information that we have here, such as names, credentials, financial data, and so on. And below we have a breakdown of each one of the columns in this database that have already been classified as sensitive. Now, in addition, we see above that we still have some recommendations for classification. So this is the intelligent part where we're actually scanning the database and discovering what else could potentially be sensitive here and what we think you should classify also. By the way, what you're seeing here is also the report, which also can be exported similarly to what we saw with VA, with the vulnerability assessment. You can export this report on what sensitive data you have per database. But let's click into the recommendations. And here I see that I have a set of additional potentially sensitive data columns that we think we should be classifying. So if I just kind of select a couple of these, or I could select all of them, but I'll select a couple and I'll accept those recommendations. And as you can see, they automatically gave me again, a classification, an information type, and a sensitivity label, right? So automatically, the phone and the email and the city were all classified automatically as contact information, and we think that the category here is confidential related to GDPR. But I can always alter these. So if I've accepted these recommendations, I can say, well, yeah, this is classified, but it's not confidential GDPR. It's actually just confidential, and I can give it a different information type if I want. So these currently are the set of information types that we support. By the way, what you see now is a built-in set of information types and classification labels. Again, this is a pretty new feature, still in preview. Eventually, the plan here is to enable you to customize the information types and customize the sensitivity labels that you have here so that they can be, again, tuned and customized to your environment. So I'm going to accept these recommendations and click Save. And now I can go back to my overview, and I see that there's a slightly different view of what is the current status of sensitive data within my database. So that's the sort of data discovery and classification element. But the second element is the actual information protection, the actual protection of this. So what we already support by way of sort of protection, or at least tracking, is we've actually integrated this capability with auditing. So as your database auditing is working and logging any activity taking place, we actually have information on when particular pieces of sensitive data are being accessed. And you can actually get a report from your audit log specifically on when and what sensitive data was accessed in your database. Let me quickly show you that. I have a couple of queries here that are accessing my customer table, which has sensitive data in it. So if I run this query, and then I think we just now added email address and phone to our sensitive data, so I'm going to run this one a couple of times also. And now I'm going to take a look at my audit log. And not only the audit log, but I actually want to look only at audit records where the sensitivity information exists. So I only want to look at audit records where sensitive data was accessed. And this is looking just at the last 2 minutes. So I'm going to run this query to look at the audit log. And as you can see, I have the record here saying, okay, here is a record where sensitive data was accessed. And I have all the audit log information. You can see that, including the query itself that was run, right? This is the select that was run. And if I go over here to the end, then I can see the data sensitivity information actually in the audit event. Okay, so I can see that this particular query accessed data that's classified as confidential GDPR, and also that's highly confidential and related to GDPR. So we have a way to basically track when the sensitive data is being accessed. And so that's one element of protection. By the way, looking forward, even beyond this, we're actually going to be able to trace when the sensitive data leaves the boundaries of the database. So we're actually working on a capability here that you'll see coming in the next few months, where any third-party application, for example, that queries the database and does access sensitive data, that sensitivity information will actually flow back with the data to the calling application. And the calling application that can be aware of that, so they can actually read that as part of the protocol, will be able to then apply protection measures. So for example, think about Microsoft Excel reading data from the database. It then goes into a spreadsheet, but that actually contains sensitive data, and Excel automatically encrypts that file. So one last capability that I wanted to show you as part of advanced threat protection is our threat detection capability. So as we said, what this is doing is continuously monitoring the database for activities, baselining what's considered a kind of normal or usual activity, and detecting anything that's anomalous or unusual that's taking place. And this is on, and it's working, and I see that I have a set of alerts here that it's already found. But what I'd like to do is actually attack the database and test threat detection and see if it actually discovers that. So for that purpose, I have this nice little, very simple sample application. This is kind of a web front end, and that same database that we've been working on is the back end for this application. So anything that I do here actually sends requests to that back end database. So if I'll log in here, then that will send a request to the database. Just a second here. Make sure I get my credentials right. Yeah, and then my sample application, again, is reading from that back-end database all this information, which could also potentially contain sensitive information, like contact information and so on. And I can run searches here that, again, do all sorts of stuff to let's see here, like that. Okay, and query the database and return data. So I have some information here, and I know that this application is actually vulnerable to SQL injection. So what I'm going to do is try to break into this with SQL injection and see what happens. So I'm going to put in this classic SQL injection attack. So what I've done here is put in a SQL statement that automatically kind of resolves to true and see if I can bypass the login authentication mechanism and just break into the database. Oh, I just did that. So that means I just got in without my credentials using SQL injection. And I can do other fun things like run this slightly more complex query that also performs an interesting SQL injection attack. I run a search, I send again this kind of complex SQL statement, and I get this error. But as we see, as part of the error information, it actually tells me that Zachary Moore, whose credit card number is this, had a failure. So yeah, I just got some interesting information here, and I'm ready to go. So unfortunately, we've just been attacked with a SQL injection attack. But what I'll do now is, again, we have threat detection luckily enabled on this database, so I'm going to go over to my email. And I see that I just got a new email message saying that we just detected a potential SQL injection on this database. And it gives me information for that it may be a SQL injection attack, information on exactly what's the server, what's the database that was attacked, what was the source IP address, what's the name of the principal that logged in, and so on. This all happened through my application, though. That's not going to help me much. But I can actually take a click here to actually view the vulnerable SQL statement. So I can see exactly kind of what happened, and I can then go and investigate the audit log, see what was the suspicious statement, what took place around the time of the attack, and see if I can get more information about what was this attack on my database. So this comes up, and I'll see kind of audit records that have to do with SQL injections, and once this comes up, we'll see the query that I just ran. Okay, so while that comes up, what I'd like to show you is that then shows up also in our advanced threat protection. So as we can see, if you remember before, we had 12 alerts here, so now we have 13 alerts. That means we've just recognized a new potential SQL injection. And if I click on here, then I can see basically a central view in Azure Security Center, which is our Azure kind of central command and control for managing all of our security. And this shows me all the different alerts that I have on my different databases within my subscription. So I can take a look at those. As we said, beyond identifying SQL injections, we also identify different types of attacks, such as potential brute force attempts, logins by potentially harmful applications, unusual sources, those types of things. And again, each one has details about the attack and different options for how this can be locked down and remediated. Okay, so check this out. See, make sure that your database is protected with this active monitoring capability. Okay, we'll go back. Okay, so just to quickly recap all the intelligent capabilities that we talked about today. We covered in the area of performance, intelligent insights, which give you kind of upfront information about what types of kind of deviations in performance you have or disruptive events, and information on how to do a root cause analysis on those so that you quickly can get down to the source of the problem and resolve performance issues. You saw automatic tuning, which is that magic that just kind of automatically improves your query performance as it goes without you even having to think about it, which is amazing. We also took a look at the different intelligent security capabilities. We just saw threat detection, which automatically monitors your database for suspicious events, notifies you, tells you what to do in case there was something suspicious. We also took a look at vulnerability assessment, which is constantly kind of scanning your database for vulnerabilities, notifying you of any vulnerabilities or deviations in your baseline state, and data discovery and classification, which automatically discovers and classifies potentially sensitive data and lets you then label that and track that as it flows through different areas. And all these capabilities are really available through a number of different sort of usage options. So whether it's in Azure Log Analytics, Velko showed intelligent insights that get streamed to SQL Log Analytics, and you can see the data there. The same goes for auditing, for security, and so on. You can use PowerShell or the portal, which we showed, or other APIs to access this stuff. So it really is available through any means that you're comfortable with as a developer to actually access these intelligent features. So now I'm going to hand it off over here to Centurion and Jeanette to talk about the success story of a particular customer, Finastra.
Good morning. My name is Centurion Sivanandan. I'm a cloud solution architect at Microsoft.
And I'm Jeanette Kasanovitz. I'm a senior director of development at Finastra.
So today, I'd like to introduce you to Finastra. Finastra is a global ISV, and they're using SQL Database as part of their cloud transformation journey. Finastra's software and financial solutions are deployed to banks, on-premises data centers, Finastra's own data centers, and into Azure regions worldwide. Their software is used by top 48 banks worldwide, and they have a customer range of over 9,000. Finastra produces a lot of software that you and I use indirectly, whether that is to get paid by our employer, to pay our bills, or to actually buy a mortgage, buy a house, and request a mortgage. So today, I'd like to talk about a product that Finastra has deployed to Azure called Fusion MortgageBot LOS. It's a loan origination software that banks use when you and I need to purchase a house. And this is what they use as a tool to approve and fund the mortgages for us. By moving to Azure, we're able to scale out this environment and handle performance and demand at the scale of 25 million requests per day. This is used by banks and credit unions in the United States, and the customer base is continuing to grow. This year, we're poised to close 350,000 loans. That's 350,000 houses being mortgaged through this tool. This is a journey for us. We spent about 9 months in 2017 working through the patterns. And this is from planning to development to migrations of databases, as well as mitigation and stabilization. So to talk more about this journey, I've asked Jeanette to join me today. Jeanette, I mean, to the audience here, let's start with the basic question of why SQL database?
So when we started the migration of the LOS to Azure, we were currently on SQL Server 2008 R2. So clearly we needed to upgrade our platform. So we took a look at SQL Server 2016 and SQL DB. And our platform strategy has always been to go fully PaaS. So this seemed to make the most sense for us to take that first step forward into PaaS services. In addition, we knew that there was a lot of benefits for us in our platform. Being able to scale to meet the needs of our individual clients was huge for us. And we knew that our DBAs with SQL DB would be able to focus on things like performance and architecture and design instead of worrying about infrastructure and maintenance.
And Jeanette, this is a multi-tenant system, and you've got customers who have high demands, and you've got customers that are smaller, and you're across the United States, so you're working with multiple time zones. How are you able to scale and meet their demands at their own time?
Yeah, so as I said, for us, meeting those clients' individual needs was really the most critical part of this platform. We decided to use elastic pools in order to be able to provide the resources that each of our individual clients needed for the best performance possible. It also ensured us a cost-effective way of managing underutilization. So we can take our elastic pools and we can, based on increased demand on the platform, we can scale those pools up. We can also isolate individual client databases that may have particularly high utilization. We also use metrics in order to be able to scale dynamically on demand for peak utilization periods.
Fantastic. So, and you've got a cross-functional team, Jeanette, but it's a small team, right? So with 800 financial institutions using this product, how are you monitoring and managing all these databases and all the changes that take place day to day?
Yeah, I think we just saw a lot of how we're doing that, right? We use OMS and SQL Analytics extensively in the monitoring of this platform. So we have alerts configured for long-running queries, database weights. We're watching our elastic pools very carefully for DTU utilization so that we can scale, as we talked earlier. We also have SQL threat detection enabled across all of our logical servers. So we get alerts, real-time alerts for SQL injection, incorrect usage of parameterized queries, non-SA login attempts on the master database. So these tools have been extremely valuable for us.
Awesome. And as we were saying from Ronit's presentation about classification, you're in a highly regulated industry.
Right.
So how is moving to Azure in general, and specifically SQL Database, helped your security posture?
Yeah, so we're in the financial industry, so we are subject to a lot of auditing and compliance, including SOC 1, SOC 2. The data that we're dealing with is frequently PII, so we have social security numbers. We need to worry about encryption and data access monitoring. We have Azure AD enabled, and we're using multi-factor authentication along with security groups to handle our database access permissions. In addition, we have also with TDE, so transparent data encryption, we know that our data is encrypted at rest, including log files and backups. We're also starting to look into additional security features such as always encrypted, and we're going to try to implement that soon. The security features of SQL DB have really enabled us to make sure that not only is our database secure, but we're also able to meet industry requirements and standards.
Thank you, Jeanette. And the final question is, this was a 9-month journey for us. About 5 months of this journey was spent migrating customers. We migrated methodically in batches, and the purpose was to make sure that we can learn from the platform as we move. Jeanette, could you share a little bit about the migration strategy?
This is actually my favorite question. So I actually really want to acknowledge the team that worked on the Azure migration. We were very fortunate to have a cross-functional team, kind of like true DevOps. We had developers on this team, we had system engineers, we had network engineers, we had an amazing DBA, we had a cloud architect from Microsoft working with us, Santhuran. This cross-functional team was able to define an automated approach for migrating our clients into Azure in waves. So the batches he talked about were waves. We have over 20 terabytes of data that we needed to move into Azure. So enabling us to migrate in waves, we were able to meet the time constraints that we had. But we also had the ability to incrementally add load into our platform. So we could monitor our application and scale as necessary as we were adding more and more customers onto that platform. The actual migration process itself was pretty straightforward. The clients that were in a particular batch to be migrated, their database was backed up, restored into a working environment. We then scripted out all of the objects, so functions, stored procedures, views, then we removed those from the database. We used SQL package to export the backpack, and then we copied that backpack into Azure to a very powerful server. That server's main job was just to import that backpack into SQL DB. We reapplied all of our objects. This process was executed thousands of times between our UAT and our production platform without a single failure.
That's the favorite part. Thank you, Jeanette. I want to end our presentation with 3 things. The first is, by leveraging Azure SQL databases, this product team is poised to innovate faster. Specifically, the engineers, the database admins, the architects, we're focusing more on business value. How can we add more value to our customers, right? As opposed to looking at infrastructure, looking at monitoring and management. Second point that I want to make is what Velko covered earlier this morning, which is advanced analytics. We're fully integrated into OMS. So application logs, database logs, Redis logs, and so on and so forth are fully deployed with OMS. So we're able to monitor, mitigate any anomalies before they become problems that impact the customers. The final thing is this elasticity of Azure. We're able to scale out our environment based on demand. So being in the financial industry, month ends is probably the busiest time. And we scale out and meet that demand, and then we scale back down at the beginning of the month. Right? Being able to do that allows us to really be more financially and fiscally responsible, at the same time give the power that the customer expects from a product like Mortgage.Bot LOS and Azure. Right? So I hope you're using Azure SQL in your projects. If you're not, I recommend you to try it. You saw some of the great features. And I'm really looking forward to seeing what you can build. Thank you very much.